Hey everybody, so welcome back. We're going to be talking with Merle next. Now, Merle is the creator of a web component called Doodle. So before we get to talking to Merle about, who he is and why he wanted to create Doodle, I think we should explore what even is the need for Doodle, right? And let alone what is it? So to start from the top, maybe you've worked with the 2D canvas. You've created a canvas element, you've created a 2D context from it, and maybe you've done some painting on that canvas through JavaScript. There's a whole other context. There's the Webgl context, and it's super hard to work with, right? I can't name many developers who actually explore that API all the time. They're mostly creative coders, I feel like, because it's very heavily computer graphics and it's very low level. But if you take a look at some of the stuff that people are doing with WebGL context, we're making full-blown 3D applications here with libraries like Three.js or Babylon.js. So if you look at the Three.js demo page here, let's load up this pinball example. It's pretty cool. This is not a 2D image. This is a full 3D scene, so let's go. You can already see, look at these camera angles. It's zooming. It looks like a console game, honestly. Okay, here I am. We're going to launch the ball here. The colors and the models are looking great, like playful and fun. Yes, I'm keeping my ball. I'm keeping my ball in action here. And I just lost it. That's okay though. This is a great example of exactly what I'm talking about that you can create with that WebGL context. But the thing is, with libraries like Three, with libraries like Babylon, there's a lot of code there that they themselves made to make it easy to import 3D objects, set materials, move objects in 3D space. You can't do any of this stuff with your browser's API as is. So to show you what you do get natively, let's check out this code pen. Here we're drawing just a simple multicolored triangle. I feel like we could draw this pretty easy with CSS, but we're drawing this with WebGL. And so right off the bat here, we're creating a canvas, we're creating a WebGL context, and then we're doing so much stuff here with this WebGL context. We're setting vertex positions for the points in our triangle. We're doing the same for colors. There's a lot of stuff here, but at the end of the day, the most important bits here are the vertex shader and the fragment shader. And so really, the rest is just boilerplate stuff that more or less is pretty common to anything you might want to create with vertex and fragment shaders. You might have different variables or uniforms, they call them. But really, the fragment and vertex shaders are all you need to create some awesome stuff. So how can we get rid of all that boilerplate? Well, let's take a look at Shader Toy. This is called Shader Toy. I know, so Shader Doodle is Merle's project, and we'll be covering that next. This is Shader Toy. And so this is a complete cloud-hosted thing that a guy named Inigo Quiles, I hope I said his name right, he also created this VR animation and painting application called Quill. But these are a bunch of shaders. So we can look at some simple ones like this one. This is very abstract, a lot of colors that are kind of blurring into one another, and there's significant math here. And even something this simple, I wouldn't even know where to begin to start to create something like this. But you can see, like, this is all just, I believe it's a fragment shader, and this is all you need. There's no complicated setup of all the stuff we saw in the triangle demo, just getting, setting up your canvas, setting up the context, clearing buffers, working with programs. All we need to do here is focus on our fragment shader. But then you can look at some of this other stuff and it just boggles your mind how you can do a scene like this with pure math, pure graphics code. How do you even come up with how to do something like this? I don't know. But you can see here there's lots of math and graphics code that went into this. And so you can do some amazing things with shaders. And honestly, if you can manage to do this, I'm sure they're not maintainable. But if you can manage to do this, these things are a lot more performant than something like Three.js or Babylon would be, just by the nature of we're just dealing directly with the GPU here for the most part. Now, this is where Shader Doodle comes in. So here's the Shader Doodle GitHub page. There's a lot of cool examples. It's a lot like Shader Toy if you look at some of the examples. There's some cool looking stuff here. Now, the key difference for Shader Doodle here is I can pull this repo down to my local desktop and start working with this. So when I look at this demo page here, look at this. I'm dealing with a web component. This is the custom element Shader Doodle. And then that's the only thing I need on this page, right? I have a script which contains my fragment. And honestly, we were talking about slots in the last episode. I don't even think this is a slot. This does not need to be rendered. It's just a piece of information that gets wedged into the web component and does not need to be rendered. And so I think Shader Doodle just sucks this in and uses this text to construct the fragment, the fragment shader. One of the worst aspects of working with shaders like this is, this is not JavaScript. This looks more like C, but it's a shader language. And your code editor is going to support your shader language. And so you're just working with it as a string. And if it's broken, you're going to get bugs. And you're going to have, honestly, in my experience, very terrible bugs that aren't super helpful. And so there's a lot of patience you have to bring to creating graphics code like this. But at the same time, that's a terrible aspect to work with. But honestly, there's no boilerplate setup. Just like Shader Toy, you don't have to worry about creating your canvas. You don't have to worry about your context. You can just focus on your fragment and vertex shaders and just put them inside your web component. And so this is a great alternative to Shader Toy, where I can just pull all this stuff onto my local computer and just play around. That's what I like to do. I honestly don't like working with CodePen or any online editors. I like bringing everything locally. I feel like this is a really fun library made for someone like me. Now we can get a little more complicated too. So Shader Doodle supports textures. We can have, graphical textures or even a video texture as we see right here. And again, I don't think this is a slot. This is just a custom element that gets added to the Shader Doodle DOM. It's not rendered. It's just used for reference. So once this gets added, it's going to look for the texture and try to wire it up. But when we look at this, check this out. It's a video that's playing. And of course, it's Big Buck Bunny. This is an open source movie. I think it's by Blender. So legally speaking, everybody uses this because it's free to use. But the important bit is we're making these wavy lines. We're warping the video as time passes, and this is the work of this shader right here, this fragment shader. So that's pretty cool. And when we do sit down with Merle, you'll hear about some of the uniforms he supports. Uniforms are kind of outside variables that you can set up and consume things from the outside world. There's some kind of setup under the hood here to use music, and I'll turn up the volume here. We can hear music playing, but also this music, the amplitude, is controlling the graphics real time in our web browser. And this is all done just through this shader right here, and it looks like a pretty simple shader, just with this extra SD audio custom element right here, right in the Shader Doodle tree. And in addition to audio, we have some abilities to, follow your mouse, listen to click events. So yeah, it's pretty nice. We can just reach in and get mouse coordinates right here. And in addition to the mouse, of course, we have the resolution, which gives you the resolution of this entire shader, this component we're working with. So yeah, this is a very fun component to play with, and I can't wait to do that. We're going to build an app with this. But before we get there, like I promised, up next, we're going to talk to Merle, the creator of Shader Doodle. So stay tuned.